My name is Gökalp Taner. I'm working in Yozgat Bozok University Computer Engineering Department. In the study, we are working about determining the digits of Turkish Sign Language using deep learning techniques. Sign language is a physical language that enables people with disabilities to communicate with each other by using hand and facial movements as a whole to express themselves. It is very important that the sign language is learned by everyone and used as a communication tool in order for the disabled to adapt to social life and to express themselves easily. For this reason, people's learning of sign language, which are specific to the country's own spoken language, will increase the quality of life of people with disabilities. As stated by the findings of the research carried out by the World Health Organization in Europe in 2018, 34 million people with hearing impairment have been identified. It's estimated that this number will approach 46 million in 2050. So, the World Report on Disabled states that individuals with hearing impairments generally have difficulty interpreting sign language. According to a study involving 93 countries, translation services are not available in 31 countries, and the number of translators authorized for translation service in 30 countries is 20 or less. With the developing technology, it is necessary to benefit from artificial intelligence technologies in order to eliminate such problems. In the study, the success of deep learning architectures in detection numbers from 0 to 10 for Turkish Sign Language has been examined. In the literature research, it is seen that studies on sign language are quite limited in Turkey. On the other hand, the number of studies in this field in the USA is quite high. Comparative analysis of similar studies in the literature is shown in table. You can see the studies from the table. For example, Aysel Matur et al. They study about containing 500 images for 26 English alphabets, and they used the method CNN, and they tried to 91.16 degrees. So they have studied about the English alphabets, and another study you can see different studies have been for the sign language using different images. So there is not enough study about the Turkish Sign Language. So that studied the dataset consists of 12,981 images of Turkish Sign Language containing numbers between 0 and 10. Images were obtained with a 1080p resolution camera at a frame rate of 30 fps at a focal length of 26 mm in a plain background font in RGB color. We have studied in the study about our dataset. We use our dataset, and you can see the images of numbers used in Turkish Sign Language. We take these images from a camera. In the study, classification processes were performed on images using the ResNet 50, VGG60, DenseNet 201, Inception V3 architectures. For the detection of hand movements in sign language, a CNN model was created and the classification process was carried out for the numbers between 0 and 10. As a result of experiment, success and loss graph of the test and training data at the end of 30 epoch of deep learning architectures are shown in figures. You will see the figures. Performance analysis graph of models A, B, C, D, and E, 5 different deep learning models used. You can see the train accuracy, train loss, validation loss graphs in the study for different deep learning algorithms. You can see the epochs in accuracy at the end of the 30 epoch. The accuracy is going to high. So when the performance of the models were compared, it was seen that some models reach maximum accuracy and some architectures change their accuracy according to number of epochs. At table, it appears that the accuracy of VGG16 and DenseNet 201 architectures increased after 30 epochs. We have studied in 10 epochs and 30 epochs. We have seen the difference at the end of that. The epoch is then important for to learn the accuracy of the work. So at the end of the 30 epoch, the architectures have a good scores. While there is a slight decrease in CNN and ResNet 50 architectures, it is seen that the accuracy value of Inception V3 architecture doesn't change. The fact that the number of class is 11 is effective in the high classification success of the numbers. As the number of classes increase, the complexity will increase, so there will be change in the accuracy values of the architectures. On the study, we show that recognition of Turkish Sign Language numbers with hand gesture is carried out with different deep learning architectures. What we want to do in the future studies, studies can be carried out with images, including letters and numbers in different conditions. Turkish Sign Language numerals and Turkish Sign alphabets can be compared with different datasets and new methods and using new models. In addition, different CNN architectures that can increase accurate prediction can be used in studies. So different works can be done in Turkish Sign Language in this time. Thank you very much.